Welcome to the 3 days webinar series in Exploring Research Career Paths in CSE and ECE, organized by the Department of CSE.
Just as an intro, I would like to tell all the other talks which we are gonna listen in this webinar series. It will be more of very technical in nature, but this talk is kind of a primer, I would say, or maybe a kind of bird's eye view about research in IT. We'll start with a very basic thing. So what is research in IT? Obviously, the next question will be, why do you want to do research in IT? The next question is how to do research in IT, right? So just like in any other domain, certain things are kind of common, but there will be certain aspects which are kind of different from other domains, right? Usually what I would suggest is aim for a topic that not only contributes to academic knowledge, but also a topic which has practical implications for businesses or society. So what we have seen so far, we have seen what is research in IT, then we have seen why to do research in IT, then we have seen how to do research in IT, and in that specifically we have seen how to identify a research area based on things like Gartner and the Forrester reports, all these aspects.
Thank you, Abin sir, for enlightening us with your knowledge on the research prospects in the IT field.
A career in computer systems, opportunities, challenges and rewards. Now what has happened is when you start reading the research papers, you have actually gotten to the forefront of the human knowledge. And when you do your work, you've managed to slowly push this boundary slightly. You just make a very small dent in that boundary of human knowledge. So you can do research even if you're not doing PhD. You can be doing PhD but still not doing research. There are more PhDs, computer systems PhDs in the industry than in academia. So it is not that everyone who gets a PhD in any of these computer systems will have to go to academia and teach, and there is no jobs in the industry for them. That is not the case. In terms of rewards, any solution is potentially revolutionary, right? You can also write to me on this email ID. That's the preferred mode of communication.
Thank you very much for inviting me and also giving opportunity to deliver and repeating the topic related to advancement in IoT for real-time applications. And in this particular topic, I would like to cover the fundamentals of IoT and what are the development happened in the past few years, especially in the IoT field for the real-time environmental applications, and the case-to-case that we can see along with the codings also. First, you need to understand what are the basic elements of the IoT. These 5 points are the basic elements of the IoT. Many of them are getting confusion between the IoT and M2M. For example, the game vending machine is there. You go to game vending machine, you just swipe the card, sensor is there, barcode is there, or maybe any strip will be there. Accordingly, you get 60 rupees or 70 rupees 1 hour, or maybe 1 minute, the time will be on so that you can play. The IoT means not only the one traffic signal, the entire traffic signal should be synchronized in a common platform, and anyone who violates the rule, and immediately the SMS has to be popped. Right now in AI camera, they have placed in entire Kerala and they are capturing, right?
Thank you, sir, for sharing your knowledge and experience with all of us and clarifying our doubts in the fundamentals of IoT and also specifying the difference between M2M and IoT. Kumar to deliver the talk on bioinformatics, opportunities and challenges for a researcher.
Motivation for this particular, maybe say this presentation and also for maybe the bioinformatics domain itself is we have to define what is bioinformatics. So if you are interested, then 50% maybe you have succeeded. So you should be passionate actually to maybe here the thing is that you can actually be if you are more creative, okay, you can actually look into or you can actually imagine this biological data into a different very different way. You look at the biological data different way. Okay, you structure the data in that particular way, and that can actually lead to maybe a different kind of analysis. Okay, fine. So these are actually primary databases. As I already mentioned, the GenBank is there. Again, so for example, you can actually look at this data at different levels. And the interesting thing is that nowadays we are having AI and ML algorithms. So all this can be applied, reinforcement learning. Okay, so that can be applied to this data. But the interesting thing is, first you should understand the process or the mechanism of these molecules, how they really behave. Then only you can actually model them, okay, such things into an abstract way. Then you can apply any machine learning algorithm or whatever. So that is a challenge. Validation is a challenge. Handling data is another challenge. Okay, maybe scaling of your algorithms to large data. Okay, obtaining the data is also a challenge.
I'm here to give a talk on the mutual coupling reduction technique for 5G massive MIMO antennas. And I'm planning to give some in-depth survey from phased array network to base stations communications. So now the MIMO is basically, it's a multi-input, multi-output communications, primarily used for the improvement of the data rate, for improvement of the multipath propagations, and also for the improvement of the signal reliability. So now whenever you are talking about the antennas and whenever you are connecting multiple antennas together, there is a mutual coupling which plays a very important role. If we come to the mobile communications or the communications generations, which is started from 1G, 2G, 3G, 4G, 5G, like that, at present 6G, then what is this massive MIMO? This massive MIMO is basically basically the additions of two things. One is the spatial multiplexing and one is the beamforming. Now we have an understanding about what is MIMO, what is massive MIMO. Then what would be the next thing? The next thing will be that why we want to use massive MIMO communications. So now these are the 5 challenges that one can think of whenever you are dealing with the massive MIMO communication system. Now, whenever you are talking about the mutual coupling, first thing is that what is mutual coupling? There are some important facts. So all such things, because of this kind of a cross coupling, all such things will be impact to your antenna system. So let me tell you one thing, that this mutual coupling will be iterative in nature. So now coming back to the mutual coupling, then what are the multiple techniques by which you can reduce this mutual coupling? Now we will be now doing the case studies of designing the mutual coupling reduction techniques at a 28 gigahertz frequency. Now, what are these filtering techniques? Now, to get the filtering technique, one can always see the filtering actions by placing the same EBG on either side of a microstrip line. Now, once the optimizations of an antenna is done, then what we did, we are creating this, we have checked the antenna radiation performance, and the radiation performance is also good. Then the next stage is to make this idea, to print this idea on the PCB. So that is all about the antenna efficiency. Next is called channel capacity loss. The next obvious question one can think of that, okay, I have an idea about the 2 array antennas. Then what will happen if we use the multiple arrays of antennas? What will happen if the mutual coupling is happening over the space wave? Now, to overcome the space wave coupling, what we did basically like as follows. We have 2 antennas, and in between we are creating a wall. Now, as a conclusion, so let me conclude. So initially I gave you an understanding about the applications perspective of MIMO and massive MIMO communications. So all these things are discussed, and please remember, before you are doing any exercise, first you have to know the applications. To help that particular applications, you may have to do multiple, or you may have to perform multiple studies, not restricted to only to the antenna related measurement, but something related to the communication standard also, so that you can present your circuit, so that you can present your system holistically.
Objectives of 6G engineering, what exactly is it, and how not only the students from the electronics background, but also from the computer science background can be a part of this 6G engineering research, which is a hot topic of research not only in India but all around the world. So here I am showing one. Let me just put it here. I'm showing one turtle which is having one antenna on his top, and he is wearing a VR set, and this is actually a gist of what we're talking about, 6G engineering. The hologram is where your replica will be standing somewhere. I will be delivering a talk in my real form in IIIT Kottayam without coming over there, and maybe I will be also speaking Malayalam over there. One more thing, now we will be talking about the research. Okay, so now if I'm talking about the communication and the sensing approach, apart from that, now let's come up, this is most of the technical talk that I have discussed, the technical aspects of 6G engineering, what I have discussed. Now coming back to a point, what exactly is the opportunity? 6G is not only about the antenna. 6G requires AI and ML. I must tell you, it will not be only requiring electronics and computer science engineers. It will also be requiring mechanical engineers. They will be working on 3D printing technology. Like I'm talking about the global market, right now is having a CAGR of 100 crores in 2022. And by 2030, we are expecting it to grow by 11%, which is 300 crores. Because that is what the need of the hour is. And if I'm talking about the key players where you will be getting placed, where these people will be happily calling you for the placement scenario. So let me give you this kind of an example where I just screenshot all of these, not only from the industries, but also from the academia.
I'll be talking about the geometric dispersion problem, which is the one type of geometric dislocation problem. Let's consider this island. Let's say we have this island here, some barren island. The country wants to, the government wants to establish some plants here, some obnoxious plants, say oil storage plants or nuclear plants or something. I want to disperse these plants as much as possible on the boundary of this island, right? Something like this. And this is a K dispersion problem in general, without any restriction on the points, right? And then we went on solving the problem. We went on resolving the complexity of this problem. Let us consider this distribution problem here. The same problem, but you are now given a radius r, some radius r. Now, let's say we have packed j disks so far, and you want to place the next disk j plus 1 disk. Right? So the total time will be 2 raised to k n square log n times log n, which is log square. So this is the total time this algorithm takes. So there is this notion called Varana diagram. Point in this cell, you can see my mouse cursor. You can see the movement, right? So there is a point here, and there is a region corresponding to this point. So that region is called Varana cell. And so if you construct the Varana diagram of these 6 points, what you get is a tree, right? So these are the base cases. And yeah, let me just go to this one. We have order of n cube case of problems in this DP formulation, and we have order of n choices to select real plane, order of k choices to part from the kappa, the value kappa. Right. So initially we gave this exact fixed parameter algorithm with running time, which is exponentially k, which is FPT, because when k is fixed, the problem becomes tractable because the algorithm runs in polynomial time. Right. When k is fixed, 2 raised to k is some constant, and the algorithm runs in n square last square, which is 1. So what is open is still is that this general Euclidean K dispersion, which is unrestricted K dispersion problem, where the given endpoints need not be in the transformation; they're already scattered in that thing, right? These problems are also actually called bichromatic separating problems in the literature. This is also a well-studied topic. Bichromatic geometric separating problems. Here you are given two types of points in the plane, that points are blue points, and you compute a separator. You find a separator which will separate these little blue points. So I want to isolate, I want to target those things. You want to place circles. So I want to find the monitoring area here. So you place circles to cover those any forces, avoiding our forces because we don't have to do anything. Forces. Now, problems that are open are these things. Unrestricted variant of the same SOFL problem, where we don't have a line here. The disk centers need not be centered on the line. The CFL problem is restricted to the board wafer corresponding. Now, the circles have to be centered on like the previous problem. Now, instead of restricting the centers and circles to a given line, suppose you want to restrict the centers and circles to the boundary of a given corresponding. The boundary of any given corresponding. So this is also open.
So today I will discuss about the topic surface electromagnetics and reconfigurable intelligent surfaces. I will also tell you the details about why it is important to actually do research in this area, and there are a lot of opportunities also both from academia and industry in this area. How to design it and how to analyze the RIS. Now we have fabricated the array by constructing actually 10 cross 15 using 10 cross 15 unit cells. That means it is a 10 cross 15 array, and we will be actually steering the beam along this plane where the number of elements are more. Or we can say we do not want the RF to be or surface current to be flowing through these lines. That means we do not want the participation of these bias lines. So we have to isolate the bias line from the top surface. How to do that? We can use actually choke inductor, which can choke the AC and pass the DC, because we want to give the DC bias. So DC should be flowing through these bias lines. So this is very small. Still we have 8 cross 16 number of unit cells in this surface, and we have designed one control circuit, modular control circuit just at the back of this. So it can control the phase values or the switching state of the pin diode. So we can increase the channel capacity by using this kind of polarization diversity also. And you can see the radiation patterns are matching very well with the ideal or MATLAB calculated result. We are yet to do the experiment on this. We will be doing it soon.
Factor Norway. These are the major international collaborations we have. Major collaborations with many MSME and DST. This is the aerial view of our campus. 99 research scholars right now we are with, and among which 32 are male, 67 are females, and also full-time scholars, 59 full-time. This is our beautiful campus, IIIT Kottayam. So we have UG programs, PG programs, integrated MTech, PhD, and postdoc programs. We have MOU with Kerala Cybersecurity Division. Also, recently, one of our research scholars, Ms. Mahima, and her guide, Dr. Panjami, they also took part in the analysis of a recent ransom attack in some colleges in Trivandrum. So, along with the Cybercom division. Then we have MOUs with DADB, MOUs with National Forensic Science University. And also we have MOU with University of Agder, Norway. These are the major international collaborations we have. Major collaborations with many MSME and DST. This is the aerial view of our campus. 99 research scholars right now we are with, and among which 32 are male, 67 are females, and also full-time scholars, 59 full-time scholars we have, and 40 part-time scholars we are having. This is our one of innovation center, which is known as GAN Innovation Center, and these are some of the products they developed. This oxyfin is an oximeter that's they actually produced during the time of Corona. And here you can see some spoon type equipment. Registered for PhD admissions can apply now. The PhD admission for August 2024 is open now. So we have, it's regarding admission category. We are having admissions through 4 categories. One is scholarship holders, the other one is sponsored. Then we have self-financing and external registrant category. Its portal is already open and 2024. And We will have the written test and interview online in between 15 and 23 June 2024, and the classes begin by 24th July 2024.
Thank you, ma'am, for walking us through the research opportunities at IIIT Kottayam.
As we wrap up this incredible journey, let's continue to stay connected and collaborated in our future research endeavors. And we look forward to see you all in our future events. And wish you all very best in your research careers. Thank you all once again and have a great day.